So hello there. We are going to take a look at a new version of Cerebral. I've been doing some work on how the signal chain works. It basically works the same way, but now there has been some new implementations that makes it easier to build large projects and especially work with teams. And all of this has happened because of fantastic input from the small community of Cerebral. So hopefully this will bring in more people so they have a chance to try out Cerebral and build some really awesome applications. So what we're going to do is just look at signals and their actions and the debugger. We're not going to actually create any UI on this presentation. So let's move into Atom here. And what we're going to do is just start out by trigger a signal. So let's create an action first. Let's just call that set foo. And the way you define a signal now, an action now, is just to create a function, because this encourages you to set a name on that function. And that's really nice to have when you are debugging the application and when you will get feedback from Cerebral in the console if you're doing something wrong inside your signals. So you should really do it this way, and there's also another reason which we will go into very soon. So let's just export this set foo action here, and the last argument, if you have seen the previous clips or introductions, we of course have this args argument, and this is where all the arguments that are being passed into the signal and are being passed like to all the actions in the chain, and actions can add arguments to this args object. And we also have this state object which holds the mutation methods, and the last argument is now called output. So I will come back to that in just a moment. So let's just say state set foo with the value from our arguments. Let's jump back to main and import this set foo from actions set foo JS and create our signal. Let's just call it up mounted and set foo, just like that. And then we of course have to trigger the signal, and this is what you would do inside your view layer, it being like Angular or React. Okay, so let's say that and let's refresh, and the signal is triggered and we see app mounted set foo, and it's setting foo, but it's setting to null because we're not passing in anything here. So what we can do now is that we can we can add a property to this action. So what we can do is say set foo input, and the input to this action, it doesn't matter where it runs, if it runs inside an action or is the first action, after another action or is the first action. We just tell now what kind of input does this action require, and this action requires a value argument, and that should be of type string. So we just use the plain JavaScript constructors here, like string, number, boolean, and stuff like that. So if I save this now and we refresh, we should get an error. So what it does is that when it runs the signal, it checks the arguments and then checks the input defined on the action. And as it states, you are giving the wrong input to the action set foo in signal app mounted. Check the following prop value. So you instantly get that feedback. You don't have to really check the stack trace or anything. You should be able to navigate to the specific spot. So if I now go to main and make sure that we actually trigger a value here, bar, and save again, and refresh, and now it works as it's supposed to do. Let's just, for fun's sake, put a number there instead. And again, it will just block the signal and throw an error. And this is because it's a bug. You should fix this. This should never happen. So so there, let's see, bar, what's that? Yeah. So that's how you can define how what kind of inputs are required for an action to run. So let's move on. We also have the possibility to use this new output. So what I'm going to do now is that I'm going to create a new action that will actually, let's see, new file, uppercase value.js. So this uppercase value will just, let's see, export default uppercase value. This will just output a new version of this value where it says args value to uppercase, just like that. And again, we can say that uppercase value dot input should be value, and it should be a string, just like that. All right, so let's insert this now into our uppercase value from actions uppercase value JS. Let's just insert this into our signal. And now when I save, it should trigger uppercase value, which verifies that it's a string, so it doesn't break. And then it will just output a new value, which is uppercase, and then that will be set on the foo state. So let's refresh now. And as we can see, now we are running two actions, uppercase value and set foo, and now it is uppercase. So that's really nice. But what we can also do here is that we can make sure that what we output to from an action to the other actions also are checked. So on our uppercase value, we can say uppercase value output is also going to be a string. So if I save that now and refresh, and nothing special should happen. But if I were to remove and just set null here now, which means that the output is not correct, and I refresh, we get an error saying you are giving the wrong input to the action set foo, and oh, check the following. Oh, sorry, it's output. So let's try again. There we go. There is a wrong output of action uppercase value in signal app mounted. Check the following prop value. This tells me that if I go to the app mounted signal and our uppercase value, we can see that the value property is wrong because we said it was supposed to be a string. So you can imagine if you're building a large application, you have lots of reusable actions across all the signals, and they start to make changes, and you will instantly get information when you start the application if you're using these actions the wrong way. So that's really nice. Okay, so let's just revert that now, output, and we should be back there. So what we're going to see now is we're going to create an asynchronous action, and let's just call that save something JS. Okay, save something arg state and output. So the way this action is run asynchronously is the way you use it in the signal. So let's just finish up this first, save something. And what we're going to do is set a timeout here. And then we are going to output, it doesn't matter, foobar, that's nice. Okay, let's save that and include it in our application. Import save something. And the way we use this as an asynchronous action is that we put it inside an array. So now this will run asynchronously, and we can check that now by refreshing. And I did something wrong here, save something, export default, I suppose. And what did I do? Let's check the terminal. Oh, I forgot the comma, sorry about that. State output. And it was export default. Let's see. Yeah, there we go. Okay, as you can see, the save something run asynchronously. Let's just add 1 second here so you can see it better. There we go. You saw it was running asynchronously, and then it's done. Okay, what you might have noticed here is that even though we have an output, if we go to our signal, there's nothing to receive that output, and we weren't notified about that. But if we go in here now and we say that save something does have an output, and that output, I have a hard time writing output, let's see, and that's a string. So if we save this now Cerebral knows about this and can warn you actually at like compile time. Even before you have started running signals, it knows that this signal chain is not correct. So it says that the action save something in signal app mounted has an output value, but there is no action to receive it. So what we're going to do now is create a new, like a dummy action here. Set something. Let's call it set something JS, and export default set something. Okay, let's import that. Set something. Okay, so the question now is, if I were to put this here, what would happen is that both these actions would be considered asynchronous, and they would actually be run in parallel, which means that this action does not give any output to this action, because they run in parallel. So what we want to do is that when this asynchronous action is done, we can put it down here, which means that all the asynchronous actions you would run inside this array, they would output to this action. So if I save that now and refresh, and hopefully, as we can see, it works. Okay, so now you start to see how you can, with larger applications and more like several team members, can very easily prevent making problems for each other. Okay, so what we're going to look at now is something called paths. So now you see that you have a very straight line, but typically with especially asynchronous actions, which most of the time are server requests, they can have like a success and an error. And with Cerebral now, you have success and error by default on all actions. So any action can lead into two different paths, either success or error. But you can customize these paths. You can have more of them, and you can change, of course, have different names on them. But let's see how we would do this now. Let's say that save something actually talk to the server, and you receive some response, and you would possibly take two different paths. So what we're going to do is type this like this to make it look very nice. And then on the success, we are going to set something. And on the error, we are going to set something else. So let's just create that dummy action too. Set something else. Set something else. And that was set something. And let's, oops, sorry, that was save something. New file, set something else, JS. Okay, like that. So what we can try now first is, if we look at our save something now, it says output. And if I refresh now, it gives a warning. And that's because now we are saying that this action can have two different outputs. So we have to define that in our action. We can still use our default output, but then we have to tell what does this resolve to. So let's just try that now. Save something, default output is success. And as we can see, we are getting a new error. And let's just read that out now. The action save something in Signal app mounted has an output definition, but there is no action to receive it. So the save something action has this output property, and that tells Cerebral that this action wants the next in line to be an action. But what Cerebral notices is that we have actually put in paths there with success and error. So maybe this action has the wrong definition, which it actually does now, because we want to convert this action to something that can be split up into a success and error path. So what we're going to do is just change from output to outputs, and then we can define success, which is an object, error, like that. So it doesn't matter if it's success or error, we will just pass the same properties. Okay, so now we have stated that this action actually wants to be can be split up into two different paths, and we have just set our default output to be success. That allows us to just call output, and that will result in success. So let's see what happens if we refresh now. Okay, so it said save something and it went to set something. But let's now change this and say error instead. So this could be like you got some bad response from the server or whatever. So if we refresh this now, and now it said set something else. So it took the other path here, just like that. And if we change to success, we can see that it chooses the normal success path again. So now you see how you can create some pretty complex flows using these paths. And normally you only use success and error. But as I said, you can define something completely different. So we can say foo bar here instead, and let's call foo instead of success, and the default is also foo. And we refresh that. Cannot find path to its foo. Oh, sorry. Of course, we have to define that in our signal too. Foo bar. Okay, so now we just change to foo bar instead of success and error. And as you can see, that works just fine. Okay, let's just revert that. Yeah, and as I said, you can create some pretty complex signals using this. But normally you will only have success and error, and you will get very, very far doing that. And also all this type checking and stuff like that, normally you do not really need that. But as I said, if your application increases in complexity, and especially if more than one person is going to work on the application, that is a very good thing to have. Now you might say that this type checking, it's way too simple for me. It's not enough just to state it's a string, number, or whatever. So what you can do is actually put a function here instead. So you can use any type checker, and you will receive the value here. So if I say return type of value is string, that will also just work. So Cerebral is not opinionated in how you do your type checking. It allows you to have really complex type checking if you want to, but gives you like just a basic type checking that should be enough for most projects, I would believe. Okay, so now we are pretty much through what I wanted to show you. I can also say that if you would have more, save something else, and you could have success and error also here. It would run save something and save something else first, and then it would start, based on the result of save something and save something else, run these other paths. So if save something was successful, it would run this, and if save something else was an error, it would run this. So you still have this parallel execution and resolving, but depending on the result of the action, it can run different paths for each action. And again, this is getting really like with complex scenarios, but I just wanted to know that you have these possibilities. Okay, cool. I hope this gave you a good insight into the new functionality of Cerebral, and I hope that it will be of use to you. Okay, thanks.